Hey developers, welcome to Devcovery. Today, we're bringing you the hottest open source projects trending on GitHub, so you don't miss any tech developments worth your attention.
Today we're taking a deep dive into a trending project on GitHub, TARS Desktop, an open source multimodal AI agent stack that's exploding in popularity. It provides the essential infrastructure for connecting cutting-edge AI models, empowering developers to build their own sophisticated, next-generation AI agents that can understand and interact with the world in multiple ways. What if your computer could understand instructions just like a human assistant? Imagine, instead of clicking through menus and forms, you could simply tell it, "Book the earliest flight to New York," and just watch it happen. This isn't science fiction. It's the very problem a new open-source project is setting out to solve. The project is called TARS Desktop. It's an open-source, multimodal AI agent stack from ByteDance. The goal here is to connect advanced AI models with a computer's graphical user interface, and its momentum is impressive. The project has already gathered over 30,000 stars on GitHub, with more than 850 added in just a single day. At its core, TARS lets you control any application using natural language. It transforms your abstract commands into concrete actions right on your screen. For decades, automating computer tasks has been a rigid, brittle process. Developers had to rely on tools that needed explicit, step-by-step scripts. Think about it. If a button's position changed in a software update, the entire automation script would break. This approach was not only time-consuming, but also limited to applications with very predictable structures. TARS bypasses this limitation in a really clever way. Instead of reading code, it uses a vision language model to literally see the screen. It interprets the visual layout of any application, just like a person would. This makes the system fundamentally more flexible and resilient to change. The project's design philosophy follows a simple yet powerful loop: perceive, think, and act. Let's break that down. First is perception. The agent takes a screenshot of the desktop. This vision-first approach is key because it means the agent can work with any application, from a web browser to a native desktop program. Next up is the think phase. Here, it combines that screenshot with your text command into a detailed prompt for an AI model. It's a lot like giving a human a visual guide and a to-do list. The model then reasons about the task and generates a plan. It outputs structured commands like click coordinates X, Y, or type this text. And finally, the act phase. The desktop application executes these commands, moving the mouse and typing on the keyboard. One of the key technical features here is its event stream architecture. This is a protocol that makes the agent's entire thought process observable, which is huge for developers. It allows them to track data flow, debug issues, and ultimately build more reliable applications on top of this system. So, what can you do with this? The applications are incredibly broad. A power user could automate booking a hotel just by providing a budget and dates. The agent would then navigate the website and fill in all the forms. Or, a developer could ask it to open a code editor and change a specific setting, saving tons of time on manual configuration. What's more, the project supports controlling both a local machine, which is great for privacy, and a remote computer. This opens up all kinds of possibilities for intelligent remote assistance. For end users, getting started is designed to be straightforward. You just describe the task you want to accomplish, which significantly lowers the barrier to complex automation. However, all this power comes with some serious considerations. The most obvious one is security. Granting an AI full control over your mouse and keyboard is a substantial risk. A misunderstood command or a model hallucination could lead to unintended or even destructive actions. The system's effectiveness is also directly tied to the performance of the underlying AI model, and these models are not yet infallible. And what happens when the agent fails or gets stuck in a loop? Its black box nature can make it very difficult for a user to figure out what went wrong or how to fix it. Ultimately, TARS Desktop represents a fundamental shift in how we interact with our computers. It's a move away from direct manipulation and toward intent-based delegation. And why does this matter? It matters because it provides an open, accessible platform for everyone to explore a future where automation could be as simple as having a conversation with your machine.
That's all for today's Devcovery. We hope these GitHub trending projects spark some inspiration for your development work. You can find all the repos mentioned in the description below. If you enjoyed this episode, don't forget to subscribe to our channel. See you tomorrow at the same time.